everybody. So here we are in kind of our last concept that we'll be discussing in our unit about sinusoidal functions, periodic functions. So we've learned the main features of a periodic function. We've learned how to develop the graphs of the sine and cosine function. And we've learned how to solve equations. So something like sine theta equals 2/3. How do you solve that? And so finally, we've learned how to transform sinusoidal functions. So finally, we get to the point, the real meat of why we learn the math. We get to modeling. So modeling is just looking at something that happens in the real world and applying mathematical concepts to it. This is the reason, this is the way that math is applied in the real world. And for many professionals who use math, the reason why we learn math. Okay, so basically first we're just going to be talking about general things to look for when you have a periodic function. And then we're going to have 6 whole examples. In this video we'll have 3 examples. And then I'll make a separate video for the final 3 examples, which are a bit more advanced than the first 3. So, first here, many real-life situations are cyclical or periodic. So the same thing happens over and over again. If data is periodic, it can be modeled using a sinusoidal function. So that means sine or cosine. And we'll talk about how you choose sine or cosine a little bit later on. So there are various ways of determining if a function can be modeled. So in the real world, it's not like, oh, I'm in the sinusoidal functions unit. Obviously, I use a sine curve to model this. No, in the real world, you just have a problem or a situation or a set of data, and you have to think, what math can I use out of all the math I know to apply to this? So the 3 major ways you can tell if you need to use a sinusoidal function are if it is inherent to the situation, so you know that the data repeats. The y values in the set of data form a repeating pattern, or when you graph it, you see it makes that nice sinusoidal curve shape. So when modeling, the most important thing is determining the key features. So first, to figure out what the axis is. The axis is the c value of the equation. Okay, and it comes from taking the max and the min and adding them and dividing by 2. So in other words, finding the halfway point between the max and the min. Then from that can come the amplitude. So that's either you can do max minus min divided by 2, all of that divided by 2, or you can just take the maximum and subtract the axis because it's the amount of space between the maximum and the axis. Then you need to find the period or the k value, okay? So if you are given the period, if you know how long it takes to complete one cycle, then you can just do 360 divided by the period to get the value of k to put into the equation. Now careful, because if you only know from a max to a min, or a min to a max, remember that that's just a half period. So you would have to double that to get the amount, the entire period. For instance, like if you know that there was a min at x equals 3 and a max at x equals, 5, then the period would be 4 because it's 2 between, so it would be another 2 to get back down to the minimum. So just be careful for that. And then finally, you look at the phase shift, okay? Now that really depends on if you choose a sine or a cosine function. Ideally, a lot of times you don't need a phase shift, okay? So you have to decision whether you use sine or cos. So generally, if a graph or data begin either at the maximum or the minimum, then you would use cos, okay? For the max, you might want to write this on the side. If it starts at a max, then you use cos. If it starts at a minimum, then you use negative cos, right? Because it's been reflected to start at the minimum. If it's data or graphs start on the axis, then it's easier to use sine. So if it's axis, then going up, you use sine. If it starts at the axis and then it goes down, you use negative sine, okay? Because that's been reflected. If the data starts at neither the maximum or the axis, then you need to use a phase shift, and you can decide whichever, if you want to do a cos or a negative cosine or a negative sine. Okay? Often it's easier to shift to a maximum or a minimum because it might be more obvious where the maximum and the minimum are, and maybe you're not given enough information to really understand where the axis is right off the bat. So cos is really used quite often, and again, because it's sometimes easier to see where the maximum or the minimum are. Now the domain and range may need to be restricted based on the situation, so make sure you're taking a look at that. Okay? So once you have modeled the situation, you use your model, which is just a fancy word for equation, to solve problems, okay? I know you need to always state domain restrictions. So let's get started with the examples. This one is just, we're not graphing or really solving, we're just finding the maximum and the minimum heights, and then the period. So our A value is 10. So our amplitude is 10, and our axis is 12, okay? Because C is equal to 12 and A is equal to 10. So that means, if you can visualize this, our axis is at 12, and then it's going to go 10 up from there and 10 down from there. Okay, so therefore the max is just 10 plus, sorry, you start at the axis, 12 plus 10. Okay, you start at 12 and go 10 up, so that's 22. And our minimum is 12 minus 10, so 2. Okay, you can verify by finding the axis and make sure it works. Okay, so 22 plus 2 divided is 24. 24 divided by 2 is 12, so it works. So that's part A. So to find the maximum, you can put a general, it's axis plus amplitude. To find the minimum, it's axis minus amplitude. Kind of just common sense. Determine the time required to complete one revolution. Well, that's just the same thing as asking for the period. Okay? So you take 360 degrees and divide it by K. Okay, so in this case, 360 divided by K. K is 3. So that's 120. Okay, and in this case, T represents time in seconds. So then therefore, it takes 120 seconds or 2 minutes to complete one revolution. Okay, and so you answer the question, make sure you use the appropriate units, and there you have it. Okay, so that's just drawing some basic information and applying it to a word problem. So that's always where you want to start. So some of these you'll be given the equation, and some of these you'll be asked to create the equation. Depends. Okay, example 2 gives you a table of values. So you'll notice I already created my x and y axis here. So I noticed that it went from negative 90 up to 180, so I made sure I had enough room to do that. And I noticed the y values, the minimum was 4 and the maximum was 8. So I didn't need any room for any negative y values. I just made sure I had at least up to 8, always with a little bit of room on top so it doesn't look too squished. Okay, so get that down, and then you just plot your points, right? Minus 90 is at 8. And I won't be totally exact here because I'm not on grid paper. Minus 45 is at 6. 0 is at 4. 45 is back at 6. 90 is at 8. 135 is at 6. And 180 is at 4. So it's clear that we have a repeating pattern, and this makes a sinusoidal curve. Sometimes you have to redo your sketches to make sure it hits all the points. So make sure you're using pencil when you create your sketches. Okay, so there that is. So now we want to determine the key features and correlate with the parameters. So I'm going to do this writing up here, but you're supposed to be filling out like period here, axis here, etc. But I want you to be able to actually see the graph as I do this. So the period is just a length of one cycle. So you can go from maximum to maximum, minimum to minimum. Be careful though, don't just go axis to axis, because this has only gone through half the cycle, because it's only gone down, it hasn't gone back up again. So I like to go from minimum to minimum or maximum to maximum. So this is one period, and it's 180 degrees. Okay, so the period you can put here is 180 degrees. So therefore, the K value is equal to 360 divided by 180. So it's equal to 2. Okay, now we find our axis. So that's the halfway point. So our max, so again, do this down there next to axis. I'll just do it up here. Our axis is our max plus our min divided by 2. So 8 plus 4 over 2 is 6. I mean, or you can just see 6 is obviously halfway between 4 and 8. So draw the axis here. So you really should be going through those points. Hope yours is a bit better because you probably have a ruler. So that's our axis. So actually that's the C value here. So our C value is equal to 6. The axis is just equal to the C value. So the axis, C equals 6. Okay? Then we need the amplitude. So the amplitude is the distance between the axis and a max or a min. So our amplitude is equal to 2. Okay, so you can put that there as well with amplitude. And that's it. So now we have to choose. So that's step 2, is finding all those key features. Now, do we need a phase shift? So always come up with period, axis, and amplitude, then move. So again, your decision on a phase shift depends on your decision of sine, cos, sign, negative cos. Now notice here that we start, quote unquote start, so like the y-intercept at a minimum. So that means we're not going to use cos because cos starts at a maximum, but that's a reflection down. So we're going to use negative cos. The reason why we want to use negative cos is because then there's no phase shift. Phase shifts are annoying. They're really easy to mess up. So if we wanted to use sine, we would have to shift it over 45 degrees. It just gets messy. So always try to avoid a phase shift if possible. So under step 3, you can write, choose negative cos since it starts at a minimum. Okay, so finally now, step 4, you take all this information and create your equation. Now this isn't a word problem in terms that like it doesn't give you a real life application, so you don't need to identify your variables. But for any other question, you should identify your variables and then make the equation. So step 4. So our function then is f at x, or we can say y equals minus, it's minus cos, so minus a, which is 2, cos, and then k is 2, and then our c value. Okay, so there you go. So you can check your equation by testing known values. So for instance, we were given the point up there, like 90, 8. So sub in 90 and see if it pumps out 8. So y equals minus 2 cos 2 times 90 plus 6. So we hope that gives us 8. So do 2 times 90 first. Get your calculator out. The cos of 180, okay, it's negative 1. Negative 2 times negative 1 is 2. 2 plus 6 is 8. So our equation worked. Okay? You could also try any other coordinate, like negative 90, 8. Or you could try negative 45, 6. I always recommend trying at least a couple, not just 0, because 0 doesn't always work if you didn't stretch or compress properly. So try a few, just throw them into your function, make sure they're right. Especially if you're doing an assignment and you're not crunched on time, there's no excuse why you shouldn't just put a few extra minutes to test it, okay? Not only does that make sure that all your work is right, but it demonstrates to me a certain level of critical thinking and reflecting ability, okay, which is assessed and evaluated as part of this course. Okay, so now we're going to get on to another one with a table of values, but this is a bit more, it's a bit more applicable to the real world. So I'm going to read this first, and then I'll get on to my chart. So the moon is always illuminated by is always half illuminated by the sun. How much of the moon we see depends on where it is as we orbit, as it orbits around the Earth. The table shows the proportion of the moon that was visible from southern Ontario on days 1 to 74 in the year 2006. So we'll assume day 1 was January 1. Okay, so day 34, okay, so January has 31 days, so that'll be February 3rd, right? That's how we think about that. So it's 0.02, 0.22, etc. Notice it's not showing every 3 days. It's kind of random what days they're showing. Okay, there's a 0.02. We get all the way down to 0.00. So this has to be the minimum because first of all, I mean, common sense, you can't have a proportion that's under 0. But there's also no number under 0. And then so 1 is the max. So again, you can't have a proportion that's over 1. That means 100%. So you always need to identify the minimum value and the maximum value in your table because that will determine the axis, the amplitude, that very important information, and you may even use it to determine the period. Okay? So we're going to complete the modeling of this problem. Okay, now I already set up my axes. Again, I knew I needed to get to 74 on my independent axis, so I went up to 80. Okay, so I went up by tens. And I know I needed to get from 0 to 1, so I didn't need to show anything negative on the vertical axis, and I only needed to get up to 1, so it didn't make sense to go up by 1, right? So that's why I chose a scale of going up by 0.2. Okay, so now you need to plot your points. You can just pause the video while I plot the points and check at the end. I mean, you don't really need to copy what I'm doing. I'm just literally just plotting the points from the table of values. So, so again, this is 10, so it's kind of guessing where 1 is. You know, you have to be a little bit careful here. And careful, the first y value is 0.02, not 0.2. So that's just here. So go ahead and get her done. Pretty thrilling stuff, eh? All right, well, that was pretty exciting. All right, so then you can kind of draw a curve of best fit, okay? So you don't want to just simply connect the dots. You want it to kind of look sinusoidal, okay? Now be careful, this wouldn't continue to go up, it would continue to go back down again. So you either just need to stop it there. Yeah, it's best actually to just stop it with the data. Okay, this is a bit sloppy, like this probably should go, we should be going up to a maximum, it just might not be hitting all the points perfectly on the way down, okay? Remember, this isn't connect the dots, it's not necessarily a perfect sinusoidal function. So what we come up with might not be exactly perfect to all the points, but it's our best estimate, and that's what modeling is, okay? So now we're going to take a look at this to identify all the key features of the graph. So let's look at the axis first. So our maximum is 1 and our minimum is 0. So our axis is clearly going to be 0.5, which is here. Okay, so this is proportion, so P equals 0.5. Okay, so therefore C equals 0.5, right? That's the axis. Okay? Now we take a look at the amplitude. The amplitude is between here and here. So the amplitude is also 0.5. Now we need to take a look at the period. Now I find it simplest to go from min to min, because we know the values of, so this was at 29 days, this was 29, 0, and this was at 59 days. So we just have to know what's the length between 29 and 59, how many days is that? So 59, the period, is equal to 59 minus 29, so 30 days. Now, for what you know about the moon and the cycle of the moon, it should make sense that our period is 30 days. Okay? So, we have all this information, so now we just need to come up with our equation. So, make sure you have the graph down, because I'm going to erase that and shift up to do the rest of the work. Actually, no, I'm not going to do that yet, because we have so now we have to decide on if we're doing a phase shift or what we're doing. Okay, so I'm going to choose to use, what do you guys think? Cos, sine, negative cos, or negative sine? What's your gut telling you? Well, I don't want to do sine because this isn't actually right on the axis. If you look at this point, it's supposed to be 7, 0.55. So it's actually above 0.5. So we don't know exactly when this curve is hitting 0.5. Also, it doesn't really start at a min because this is 0.22. It's not 0, and it's at 1 day, not 0 days. So I'm going to use negative cos, and then, or actually no, I'm not. I'm going to use positive cos. Ignore that. I'm going to use positive cos and use this as the start, okay? So that means we're at a maximum.